1.4, connecting graphs, equations, and tables. I can identify linear, exponential, and other patterns in different representations. So we're going to start by graphing from the y equals mx plus b form, where the number in front of the x is the slope and the number after the x is the y-intercept. So this first one, y equals negative 1/4 x minus 1, starts here on the y-axis at negative 1, and then the slope is down 1 and right 4. And then I'm going to continue that slope across the graph. And try to connect the dots with a straight line. Okay, this next one begins at negative 2, and its slope goes up 5 and right 2. And I'll do that again. See if this works. No. Just have to go with my wobbly hand. All right, now we can also graph from tables. We do that by plugging in the x from the table into the equation right here. So this first one would be negative 2 times negative 2 plus 3. And that, when you plug it into a calculator or do it in your head, you get 7. When you plug in negative 1, you get 5. And so on. And then you just plot these points. You'll notice that it still goes through a y-intercept of 3, and it still goes down 2 and to the right 1. Okay, let's try another one using the table. So this would be 3 times negative 2 subtract 7. Plugging in negative 1, then plugging in 0, 1, and 2. And there we get our line. Now, a quadratic function is a polynomial equation where the highest exponent is 2. For instance, x squared plus 2x plus 1, 2x squared minus 3x plus 5, negative 1x squared minus 5x minus 4. Those are all different polynomials, or quadratic functions rather, and each of them have an x squared term in them. Let's try evaluating one at a given value. So the function this time is negative 3x squared plus 4, and they want us to plug in negative 2 where the x is. So I'm going to rewrite this negative 3, but instead of x, I'm going to put in negative 2 in parentheses. And then I'll just finish writing out the rest of that equation. Negative 2 times negative 2 is positive 4. 4 times negative 3 is negative 12. And negative 12 plus 4 gives us y equals negative 8. So here we're going to plug in points from the table and evaluate them. So our first one is 0 squared minus 4 times 0 plus 1. And the answer is 1. Then I'm going to plug in 1. And I get negative 2. Then I'm going to plug in 2. Four minus 8 is negative 4 plus 1 is negative 3. Then I'm going to plug in 3. And I'm starting to see it turn around here. And now I'm going to plot these points. So I have 0, 1, 1, negative 2, 2, negative 3, 3, negative 2, and 4, 1. So my parabola shape comes down, turns around, and goes back up. Now you may have noticed that we're choosing different numbers in the table. It's important that we choose our 5x values around the vertex. This part right here is called the vertex. And on the notes, they've found those points for you. We'll be talking about later how to find that on your own. For now, let's continue to plug in the values that they give us. So we have negative 2 times 2 squared. And we get negative 6. Then I'm plugging in negative 1. Sorry, should have put a negative there. And that gives me 0. Now I'm going to plug in 0. And I get 2. Plugging in 1. Gives me 0 again. And finally plugging in 2. And that gives me 6 again. So negative 2, negative 6. And we get this kind of parabola shape this time. Okay, and one last one. So just replacing the x with the number from the table. Okay, I'll do the parentheses first. I get negative 2. That squared becomes 4, so I end up with 5. And then again, I'm going to plot these points.